Blockchain is the future of the database. The blockchain is the new database. Get ready to rewrite everything. The technology concept behind the blockchain is similar to that of a database, except that the way you interact with that database is different. For developers, the blockchain concept represents a paradigm shift in how software engineers will write software applications in the future. And it is one of the key concepts that needs to be well understood. We need to really understand five key concepts and how they interrelate to one another in the context of this new computing paradigm that is unraveling in front of us. The blockchain, decentralized consensus, trusted computing, smart contracts, and proof of work stake. This computing paradigm is important because it is a catalyst for creation of decentralized applications. A next step evolution from distributed computing architectural constructs. On distributed communications networks, Paul Baran, 1962. But this is not just a computing phenomenon. Decentralized applications are going to enable a decentralization trend at the societal, legal, governance and business levels because there is a race to decentralize everything and give power to the edge of the networks. So let's get ready to understand these concepts. The first one, decentralized consensus. On or off Bitcoin's blockchain. Decentralized consensus breaks the old paradigm of centralized consensus, i.e., when one central database used to rule transaction validity, a decentralized scheme on which the Bitcoin protocol is based transfers authority and trust to a decentralized virtual network and enables its nodes to continuously and sequentially record transactions on a public block, creating a unique chain, the blockchain. Each successive block contains a hash, a unique fingerprint of the previous code. Therefore, cryptography via hash codes is used to secure the authentication of the transaction source and removes the need for a central intermediary. The combination of cryptography and blockchain technology together ensures there is never a duplicate recording of the same transaction. What's important here is that With this degree of unbundling, the consensus logic is separate from the application itself. Therefore, applications can be written to be organically decentralized. And this is the spark for a variety of system changing innovations in the software architecture of applications, whether they are money or non-money related. You could think of consensus as the first player of a decentralized architecture. It is the basis for the underlying protocol that governs a blockchain's operation. Second, the blockchain and blockchain services. A blockchain is like a place where you store any data semi-publicly in a linear container space. The block. Anyone can verify that you've placed the information because the container has your signature on it. But only you or a program can unlock what's inside the container because only you hold the private keys for that data securely. So, the blockchain behaves almost like a database, except that part of the information stored, its header, is public. The data stored can be a token of value or a crypto money balance. So the blockchain acts as an alternative value transfer system that no central authority or potential malicious third party can tamper with because of the encryption process. It's based on the public-private hegemony, which is the yin-yang of the blockchain. Public visibility but private inspection. It's a bit like your home address. You can publish your home address publicly, but that doesn't give any information about what your home looks like on the inside. You'll need your private key to enter your private home. And since you have claimed that address is as yours, no one else can claim the same address as theirs. The blockchain can also be seen as a software design approach that blinds a number of peer computers binds a number of peer computers together that commonly obey the same consensus process for releasing or recording what information they hold, and where all related interactions are verified by cryptography. Third, smart contracts and smart property. Smart contracts are the building blocks for decentralized applications. A smart contract is equivalent to a little program that can entrust with a unit of value as a token of money and rules around the value. The basic idea behind smart contracts is that a transactions constructal contractual governance between two or more parties can be verified programmatically via the blockchain instead of via a central arbitrator, rulemaker, or gatekeeper. Why depend on a central authority when two or more parties can agree themselves and when they can bake the terms and implications of their argument programmatically and conditionally with automatic money releases when fulfilling services in a sequential manner, or incur penalties if not fulfilled. The starting point that you assume when applying smart contracts is that third-party intermediaries are not needed in order to conduct transactions between two or several parties. Instead, the parties define and agree on simple or complex rules, and they embed them inside the transactions, enabling an end-to-end resolution to be self-managed between computers that represent the interests of the users. Smart properties are digital assets, or things that know who their owners are. Their ownership is typically linked to the blockchain. Fourth, trusted computing or trustless transactions. When you combine the concepts behind the blockchain, decentralized consensus, and smart contracts, you start to realize they are enabling the spread of resources and transactions laterally in a flat peer-to-peer manner, and in doing that, they are enabling computers to trust one another at a deep level. Whereas institutions and central organizations were necessary as trusted authorities, a certain number of their central functions can be codified via smart contracts that are governed by decentralized consensus on a blockchain. Namely, due to the blockchain's role as an equivocal validator of transactions, each peer can proceed and trust one another because the rules of trust, compliance, authority, governance, contracts, law, and agreements live on top of the technology. If you fast forward to a not too distant future, smart contracts and smart property will be created, dispensed, or executed routinely between consenting parties, without either of them even knowing that blockchain technology was the trusted intermediary. Arguably, trusted computing on the web is a key tenet of the new crypto-driven paradigm. Fifth, proof of work and proof of stake. At the heart of the blockchain's operation operations is the key concept of proof of work, an integral part of Satoshi Nakamoto's original vision for the blockchain's role as the unequivocal authenticator of transactions. The proof of work is a right to participate in the blockchain system. It is manifested as a beacon of hurdle that prevents users from changing records on the blockchain without redoing the proof of work. So, proof of work is a key building block because it cannot be undone, and it is secured via the strength of cryptographic hashes that ensure its authenticity. But proof of work is expensive to maintain. Estimated cost of 600 million per year for Bitcoin, and may run into future scalability and security issues because it depends solely on the miners' incentives, which will be declining over time. An upgraded solution is proof of stake, which is cheaper to enforce but more expensive and more difficult to compromise. Proof of stake not only determines who gets to update the consensus, but it also prevents unwanted forking for the underlying blockchain, edging towards a decentralized world.